Okay, we've got a car traveling at 30 meters per second and then it skids to a stop. And we know that the coefficient of sliding friction, which is also known as kinetic friction, between the rubber tires and the wet pavement is 0.5. And we want to know the size and direction of the force of friction that the road exerts on the car. Well, let's start by completing our free body diagram. Our car obviously has a force of gravity that's holding it down, squeezing it against the road. The road creates an equal and opposite force up. And we know it's equal and opposite because the car is not moving vertically. So those two vertical forces must balance each other to keep the car from accelerating in the vertical direction. So we've got a normal force up countered by a force of gravity down. When I slam on the brakes, friction opposes the motion, and it's pointed to the left in this case. And remember, when you slam on the brakes in your car, you take your foot off the gas, so there is no other force that's causing it to go forward. Don't mistake motion for a force. Even though it's got a speed or a velocity of 30 meters per second to the right, doesn't mean there's a force to the right. Your acceleration is to the left. There has to be a force to the left. A left acceleration simply means the car is slowing down. It's the opposite direction to your velocity. So I've got a force of friction to the left only. There is no forward force acting or drive force acting to the right. Now, if I was going to take my diagram and create a net force equation, which we don't necessarily have to for this question, but F net is the sum of forces, and all I care about are forces that are in the direction of the motion. The normal and the gravitational forces cancel each other off vertically. So really, my leftover force is just going to be my force of friction. So there's my general equation. So there's two ways I can figure out the force of friction. If I can figure out my net force, ma, then I know my force of friction. But I know my initial velocity, I know my final velocity comes to a stop, but I don't have a distance or anything like that. So it's unlikely that I can get my acceleration. So that's probably not the avenue we want to use. But we also know that the force of friction right off our formula sheet is mu times the normal, where mu would be our kinetic coefficient, our sliding coefficient of friction, and Fn is our normal force, which we can figure out from our picture. So we're going to go with this equation. Force of friction is mu k times Fn. Now, if you look at your diagram, the normal force we've already said is equal and opposite to the force of gravity, and we happen to know the formula for force of gravity, mg. So I'm going to replace Fn with mg, and now I can solve my question. So 0.5 is my coefficient. Mass of the car was 750. And g, as usual, is 9.8 meters per second squared. And when I fire all that through, I get 3,700 newtons. And we say that the force is to the left opposing the motion, so we say it's a negative force. So my force of friction is negative 3,700, the negative meaning left the way I've drawn it.